Hello everyone. In this video, I'm going to be talking a little bit about my project AI Recipe Finder using cloud technologies. I am Srimedha, and in this project, I tried to combine artificial intelligence and modern cloud technologies to build a smart and user-friendly recipe recommendation system. The main inspiration behind this project was to make cooking more accessible and creative. Whether you're a beginner or an experienced chef, this tool should be able to provide tailored recipes based on the ingredients you have available at home. The primary goal here was to create an intelligent system that allows users to input their ingredients into the dashboard and receive customized recipes in real time. The components that I used as a part of this project were Streamlit for an interactive and user-friendly dashboard, Hugging Face and GPT Neo for recipe generation using natural language processing, Google Cloud Functions for processing HTTP requests serverlessly, Google Cloud Storage to store the generated recipes for future retrieval, and Google PubSub to facilitate asynchronous messaging. On the hardware side, we leveraged Google Cloud's robust infrastructure for scalability and reliability. Additionally, a local machine, which was my laptop, was used during the development and testing phases. This architectural diagram right here gives a basic idea on how the project works. So at the core, the user inputs ingredients through the Streamlit app. The app sends this request to the Google Cloud Functions, which processes the data and generates recipes using GPT Neo. The recipes are then stored in Google Cloud Storage and communicated back to the user. Google PubSub ensures that all messages are efficiently managed for seamless operations. This particular setup not only ensures real-time functionality, but also demonstrates a decoupled scalable design. As I just mentioned in the architectural diagram, these are the four different cloud technologies that I employed as a part of this project. Google Cloud Functions for scalable functionality, Google Cloud Storage, Google PubSub, and API calls using GPT Neo. Moving on to the testing and debugging phase. Rigorous testing and debugging were critical to ensure a smooth user experience. So I performed unit testing to validate individual components like cloud functions and the Streamlit interface. Integration testing was conducted to verify the system's end-to-end functionality, while load testing measured its performance under different traffic conditions. For debugging, I relied on Google Cloud Logs to trace errors and monitored the real-time console of the Streamlit app. This approach kind of allowed me to quickly identify and fix the issues I was facing during the development phase. So the capabilities and bottlenecks. This AI recipe finder has several exciting capabilities. It provides real-time recipe recommendations tailored to user input. It uses scalable and serverless cloud infrastructure, ensuring reliability even during peak usage. It integrates multiple data center components, demonstrating the power of cloud technologies. However, like any system, it has its challenges. Potential bottleneck includes latency that is caused due to the network or API requests. Some of the other limitations, such as the GPT-4 that I initially wanted to use, did not have enough limits to complete my entire testing. So I had to shift to GPT-Neo, which is a little less sophisticated model. These are some of the limitations I faced while I was trying to build the recipe finder. Moving on to a very quick demo. So this is how the dashboard looks. It is very easy to use, and all we have to do is to come into this text box and enter the ingredients separated by commas. And then as soon as we click on the first button, which is Find Recipes, we will get the recipe names, which is sweet milk toast in this case, the estimated time, different ingredients required and the quantities, and also the different steps that are to be followed to make this specific recipe. We also have two other buttons that are acting for the pub/sub functionality of this project. The publish recipe is going to act as the pub part, the publishing part, whereas the subscribe to topic is going to aid the user into being updated with all the recipes that are coming from the specific ingredients. I would also like to show this. with a different with three different ingredients. So I'm going to put onions, potatoes, and maybe tomatoes. I'm going to click on find recipes. Yeah. So we have a different recipe now. There is a different estimated time, ingredients, and steps, very similarly. So whenever I generate a recipe, I also have my Google Cloud Console, which has a bucket that is going to get all the recipes as a .txt file. As we can see here, I have created a recipe logs bucket, which has all the .txt files with different recipes that were generated from the dashboard. Uh, this is the one that we just checked for bread, milk, and sugar, and we also have one for onions, potatoes, and tomatoes that were generated today. This is the code I have running in Google Cloud Functions. As we can see, I have initialized GPT Neo model and tokenizer. We can also see a function for generating recipes where I have a huge prompt that is very specifically asking what kind of output I'm expecting from the model, and tokenizing the prompt, generating the recipe using GPT Neo, decoding the generated text. There's also some code for removing duplicate lines. Uh, so that was the main part of my demo. There were other functionalities that I initially planned to implement, like having images, but due to the time constraint I had, I could not implement that. I do plan to implement those in the future. And if you're really interested in checking it out, please feel free to visit my GitHub repository. I'll be updating all the code on all the updates that I make to my code uh, over there. Thank you so much for listening in. That would be it for my presentation today.